Okay, today we talked about scatter plots and the correlation coefficients. So we're going to describe the correlation of a scatter plot. We're going to construct one. We're also going to find the correlation coefficient using a graphing calculator. Okay, so as a review, we're going to write the equation of a line that passes through the given points. Remember that to be able to write the equation of a line, you need two things. You need slope and you need a point. So we already have 2 points, so we need to find slope. Slope formula is y1 minus y2 over x1 minus x2. So we're going to fill in those values. y1 is 5 minus y2 7 over x1 2 minus x2 6. And then we'll simplify this. We get negative 2 over negative 4, and that also reduces to 1/2. Then because we have a slope and a point, we're going to use point slope, which says you take y minus y1 equals m times x minus x1, and we'll fill in everything but the x and the y. We leave those. So to fill those in, we're going to choose one of our points. I'm going to choose the first one. So y minus y1 would be 5, and then x minus x1 would be 2, and then this m becomes my slope, which is 1/2. Now you have 2 steps. Distribute here and here. So we get half x, half of 2 is 1, so minus 1. Then we add 5 to both sides. So y equals 1/2 x plus 4. And that hopefully was a good review of how to write an equation of a line. We're going to use it a lot in the next assignment. Scatter plots. Our first type of scatter plot is a positive correlation. You can see that it's increasing. The next one is a negative correlation. We can see that it's decreasing there. And then no correlation. We can't really tell what kind of information is going on with our data. A scatter plot is a graph that shows you how to analyze 2 sets of data. Causation, this determines if one variable is caused by the other variable. Correlation is data that follows the same pattern. So you have 3 different kinds of correlation. You either have positive, negative, or no correlation. And strong correlation does not imply causation. So it says here that the following table shows the percent of Americans with broadband connections at home in a recent year. Create a scatter plot to describe the correlation. So when we go to create our scatter plot, I'm going to put this age as L1, which is also your X value, and the percent as L2. We can think of it as our Y value. So you're going to go to your calculator. Remember to go to Stat, and we're going to press Enter. That'll allow you to edit 2 lists. Make sure you put the first one in list 1 and the second one in list 2. And then after that, we're going to we're going to stat plot, which is second y equals, to see our graph of our scatter plot, and we'll go to there. So once you've put it in your calculator, you want to make sure that when you go to your stat plot window that you select a scatter plot and not any other kind of plot that we have. And our data looks roughly something like this. So here we would say, hey, it looks like there is a negative correlation. Okay, so what I wanted you to look at here is, remember the age was across the bottom, and the percentage of people who use broadband connections is our vertical axis. So this negative correlation would say, hey, because you're getting older, we probably don't have a lot of people who use broadband connection. Now, is there causation? Is it because you're old that you don't have broadband connections? And we would say no. There is no causation. Between age and using broadband connections. Okay, a correlation coefficient. This is just a statistical index of a linear relationship between two things. So basically what that means is that this is just a number that we're going to get, and it will fall between -1 and 1, and there's some information that we will learn about that. The first thing is if r is positive, then that means that there is a positive relationship between our variables. Okay, and so if r is negative, there's a negative relationship, and we'll be able to see that just by looking at our graph. And the last one said if r is 0, then there is no correlation. So our scatter plot will show that there is no correlation between the variables. What I wanted to add is the closer r is to 1, the more linear it becomes and the better the data fits together, or the closer r is to -1, again, the more linear it'll be negative, but the more linear the line becomes and the closer the data fits together. So example 2 says the table ranks the 10 tallest buildings in the world. Find the correlation coefficient, and what does this tell you? So the first thing that you're going to do is you're going to put this into your list. So to do that, remember we press stat. We'll put rank as list 1, or you can think of it as the x value, and stories is L2, and that's your y value. And then we'll enter them in our calculators and make sure that we have our stat plot turned on so that we can see the graph. So once we see the graph, it will give us an indication of what our correlation coefficient will look like. So our graph, just really quickly, looks something like this. We can see that it is somewhat negative. It's not like it's extremely negative and all of them are pulled together, or the data is really linear. So because it's not linear, we're going to say it's not going to be -1, the correlation coefficient, but it'll probably be closer to -1 than it will be to 0, because 0 indicates that there is no correlation, and we can see that this data has some correlation. So to find that correlation coefficient, we press stat, we arrow over to calc. So stat, arrow over to calc, and we're going to choose number 4. Now this will only work if you have what's known as a diagnostics on. So if you need to turn that on, you'll go second catalog, which is 0, so second 0, arrow all the way down to diagnostics on, press enter, and then enter again, and it will turn these values on for us in the linear regression part of our calculator. So when we press enter, we look for R, and R here is -0.607, and we can see that it was in between -1 and 0, closer to -1, so that does indicate that there is a negative correlation. So what does this tell us? That there is a negative correlation between our data. Okay, that should help you with your assignment 6.4, scatter plots and correlation coefficients.